Hello everyone, I hope you all are fine with your families, safe at home. And during this time of pandemic COVID-19, we care about your studies. So I shall be going to start your math syllabus. So let us start. Now let us start with class 8 chapter 1, that is rational numbers. So here is a diagram. It shows all the types of numbers in the diagram. First one is natural number. You can see here. What are natural numbers? You all know. All the countable numbers are called natural numbers. Counting starts from 1. So starting from 1, 1, 2, 3, 4 and so on. These are called natural numbers. Then let us come to whole numbers. What are whole numbers? All the natural numbers with 0. That means 0 and all the natural numbers 1, 2, 3, 4 and so on. These are called whole numbers. So whole numbers start from 0, 1, 2, 3 and so on. Right? Then the next is integers. What are integers? All the natural numbers 0 and all the negative of natural numbers are called integers. That means all the natural numbers 1, 2, 3 and so on. 0. Negative of natural numbers means minus 1, minus 2, minus 3, minus 4 and so on. All these are integers. Here are some examples of integers. Minus 2, 9, minus 5, 0. All these are integers. Then under root 49. Under root 49 is 7, which is also an integer. So all these are integers. Then next is rational numbers. Rational numbers are those numbers which can be written in the form of P upon Q. That means which can be written in the form of numerator upon denominator. See this example, 2 by 3. 2 is the numerator here and 3 is the denominator. So it can be written in the form of numerator upon denominator. So 2 by 3 is a rational number. Similarly, 3 by 4, numerator upon denominator. Here the numerator is 3 and denominator is 4. So 3 by 4 is a rational number. 7 by 8 is also a rational number. Numerator is 7, denominator is 8. See this number, minus 3.4. Minus 3.4 can be written in the form of numerator upon denominator. Yes, how? If I remove the decimal point from here, it will be minus 34 upon 10. So minus 34 upon 10, it is the form of numerator upon denominator. So yes, minus 3.4 is also a rational number. See this one. Here is a decimal number 9.454545 and so on. So here a particular pattern is repeating. 4545, 4545 is repeating. So these kind of decimal numbers can also be written in the form of numerator upon denominator. So it is also a rational number. One very important thing which you have to keep in mind about rational number is that both the numerator and denominators are integers and denominator is never equal to 0. Denominator cannot be 0. Why? Because you cannot divide any number by 0. Anything cannot be divided into 0 equal parts, right? So denominator cannot be 0. Clear? So this is about rational numbers. Now irrational numbers. All the numbers which are not rational number are called irrational. That means the numbers which cannot be written in the form of P by Q, that is in the form of numerator upon denominator, are called irrational numbers. Examples, see some examples like under root 10, under root 3, you don't know the exact value of it. It is non-ending in decimals, pi. All these are irrational number. See this decimal number 1.2434871 dash dash dash. It is non-terminating. Non-terminating means it does not end. And there is not a fixed pattern which is repeating. There is no fixed pattern. As here it was 4545 was repeating. There is no fixed pattern which is repeating. So it is non-repeating and non-terminating decimal. So this type of decimals are always irrational numbers. So rational numbers and irrational numbers together are called real numbers. So this is about the numbers. Now we are going to study about rational numbers. the number which can be written in the form of p upon q, where p and q are integers and q is not equal to 0, are called rational numbers. As I told you, it is in the form of numerator upon denominator. Both numerator and denominator are integers and denominator is never equal to 0. Here are some examples like 3 upon 5, minus 2 by 7, 4 upon minus 11, minus 2 by minus 5. All these are integers. Minus 2 here. Minus 2 is an integer, a negative integer. 7 is a positive integer. So it can be any integer, but in denominator it should not be 0. Now here minus 2 upon minus 5. Both the numerator and denominator are negative integers, right? Numerator is minus 2 and denominator is minus 5. So these are the examples of rational numbers. Now there are two types of rational numbers, positive rational numbers and negative rational numbers. Rational numbers, so you have seen, it is in the form of p by q. P and q are integers, q not equals to 0, that's it. Then positive rational numbers. What are positive rational numbers? In these rational numbers, both the numerator and denominator are either positive or negative. Like 3 by 7. Here 3 and 7 both are positive integers, right? 2 by 3. Here numerator is 2 and denominator is 3. Both are positive, right? So these are positive rational numbers. Now in these examples, minus 3 by minus 7 both are negative. Both can be negative. So yes, it is a positive rational number. Similarly, minus 2 by minus 3, minus 5 by minus 11 is also a positive rational number. Why? Here minus and minus sign will be cancelled out and it will be 5 by 11. So which will become a positive rational number. Now negative rational numbers. Negative rational numbers are those rational numbers in which either numerator or denominator is negative. Means one of them is negative and the other is positive. For example, minus 2 by 3. Here numerator is minus 2 and denominator is 3. So you can see that numerator is negative but denominator is positive. So it is a negative rational number. Here 2 upon minus 3, numerator is positive, denominator is negative. So it is a negative rational number. Similarly, minus 3 by 7, here numerator is negative, here denominator is negative, numerator positive. So all these are negative rational numbers. So what we learned, that positive rational numbers are those in which both numerator and denominator are positive or negative. And negative rational numbers are those in which one of them is negative and the other one is positive. Either numerator or denominator is negative. Now, one important point. All integers, whether positive, negative or 0, are rational numbers. That means all the integers can be written in the form of p upon q, that is numerator upon denominator. So all the integers are rational numbers. How? See the examples. 4 is an integer. It is a positive integer. Nothing is written in the denominator. 4 is simply 4. So if nothing is written in the denominator, we can assume 1. 4 upon 1. Similarly, 3 is a positive integer. In the denominator, we can assume 1. So it is in the form of p upon q. So 4 and 3 are rational numbers. Similarly, see negative integers. Minus 2 can be written as minus 2 upon 1. Minus 5 can be written as minus 5 upon 1. 0 can also be written as 0 upon 1, 0 upon 2, 0 upon 3. With 0, you can write any denominator other than 0 because 0 can be divided by any non-zero number. So as you can see, all these are written in the form of p upon q. So all the integers are also rational numbers. Now next topic is equivalent rational numbers. First point is, if p upon q is a rational number and m is a non-zero integer, then p upon q is equals to p into m upon q into m. That means you can multiply both numerator and denominator of a rational number by any non-zero integer. Let us see with an example. I have taken a rational number minus 3 by 5. Okay. Now let us multiply both numerator and denominator by 2. So minus 3 into 2 and in denominator 5 into 2. It becomes minus 6 and 5 into 2, 10. It becomes minus 6 upon 10. So minus 6 upon 10 is equivalent ratio to minus 3 upon 5. Similarly, if I multiply both numerator and denominator by 3, so numerator becomes minus 3 into 3, denominator becomes 5 into 3, so that it is equals to minus 9 by 15. Similarly, if I multiply both numerator and denominator by 4, it becomes minus 3 into 4, that is minus 12, 5 into 4, that is 20. So minus 12 by 20 is equivalent ratio to minus 3 by 5. So the equivalent ratios of minus 3 by 5 are, it is equals to minus 6 by 10, it is equals to minus 9 by 15, it is equals to minus 12 by 20, and so on. You can find as many equivalent ratio numbers as you want. All these are equal in simplest form. These are equivalent ratios because if you simplify it, after simplifying it, all will be equal to minus 3 by 5. This is the simplest form that we will study further. Now the second point, it is if P upon Q is a rational number and M is a common divisor of P and Q, then P upon Q is equals to P divided by M upon Q divided by M. That means you can divide both numerator and denominator by its common divisor. Or you can say you can divide both numerator and denominator by HCF of P and Q. See how? Here is an example, 36 upon 45. So 36 and 45 both are divisible by 9. So you can divide both numerator and denominator by 9. And 9 is also the HCF of P and Q, numerator and denominator. So let us divide 36 divided by 9. 45 is also divided by 9. 36 divided by 9 is 4. 45 divided by 9 is 5. So the equivalent rational number is 4 upon 5. Similarly here, 35 and 49. HCF, that means highest common factor. HCF of 35 and 49 is 7. So let us divide both numerator and denominator by 7. Numerator is 35 divided by 7 and denominator is 49 divided by 7. It becomes 5 by 7. So 5 by 7 is equivalent rational number to 35 upon 49. So this is how you find equivalent rational numbers. Now standard form of a rational number. Two things you have to keep in mind when you write a rational number in its standard form. First thing is that denominator should be positive. If the denominator is negative, we will write the minus sign with the numerator, right? Second thing that you have to keep in mind is that HCF of numerator and denominator, that is HCF of P and Q, should be 1. There should be no common divisor of numerator and denominator. See, as just now we have seen these examples, these are the equivalent rational numbers. Means we have written one rational number in different forms. This is a different form, this is a different form, this is a different form. So standard form is this one. Why? Because denominator is positive and HCF of 3 and 5, HCF of numerator and denominator is 1. Here the HCF is not 1, it is divisible by 2, right? So it is not in standard form. So that's what we have to keep in mind while writing a rational number in standard form. For example, this is a rational number 4 by 6. So denominator is positive, right? 6 is positive. Now we have to keep HCF of numerator and denominator 1. So HCF of 4 and 6 is 2. To make it 1, we have to divide it by 2. 4 divided by 2 upon 6 divided by 2. So it will become 4 divided by 2 is 2 upon 6 divided by 2 is 3. So 2 by 3 is the standard form of 4 by 6. Because 2 by 3 is divisible only by 1 and no other number. And denominator is positive. Now see the next one. It is 4 upon minus 6. Again, I told you first condition is denominator is always positive. Here the denominator is negative. So we will write this negative sign with the numerator, not with the denominator. So 4 will become negative and 6 will become positive. It is minus 4 upon 6. Now second condition, HCF of P and Q should be 1. HCF of 4 and 6 is 2. To make it 1, we will divide it by 2. minus 4 divided by 2 upon 6 divided by 2. Minus 4 divided by 2 is minus 2 and 6 divided by 2 is 3. So minus 2 by 3 is the standard form of minus 4 by 6. So this is how you write a rational number in the standard form. Next is absolute value of a rational number. Now what is the absolute value of a rational number? There are 2 points. First, numerical value of a rational number ignoring its sign is the absolute value of a rational number. Means you just have to write the rational number without its sign. Second point, it is either 0 or it is greater than 0. Means it is positive or it can be 0, but it is not negative because we don't consider sign. Absolute value of P upon Q is written as, the symbol is called mod. It is represented like this, mod of P by Q. That means absolute value of P by Q. It is equal to absolute value of P upon absolute value of Q. That means mod P upon mod Q. See with the help of example, absolute value of 5 upon 12. That means mod of 5 by 12. It is equals to mod of 5 upon mod of 12. Now 5 is positive, so we keep it as it is. 12 is also positive, we keep it as it is. So the absolute value is 5 upon 12. See the next example. Absolute value of minus 3 by 5. It is equals to mod minus 3 upon mod 5. Now mod minus 3. We ignore the sign. We will not put any negative sign. So we remove the minus sign here. It becomes 3. 5 is already positive. We keep as it is 5. So it is 3 upon 5. You just have to remove minus sign if it is there. Similarly here minus 8 upon 7. Mod of minus 8 upon mod of 7. 8 is negative now. Just remove the negative sign. It becomes 8 and 7 is already positive. So keep it as it is. 8 upon 7 is the absolute value. Similarly here minus 4 upon minus 5. So for the absolute value, mod minus 4 upon mod minus 5, both are negative. We will write both as positive. So it is positive 4 upon 5. So 4 upon 5 is the absolute value of minus 4 upon minus 5.